Working with I/O means a whole new world of design and the approaches to design because I/O is messy. Whether it's files, whether it's network connections, whether it's databases, whether it's whatever back-end data source inside of there, they have their own way of storing data. They have their own way of representing data, and it becomes a problem for us in our nice, clean Java application. One of the things also we want to be able to do within our solution is to reuse code. Now, often you're going to see early in your career that you can find solutions that are very similar to yours, and you can copy and paste code, and you can put it together. And often in classes, as you're trying to struggle to learn this stuff, you're going to find that to be a useful tool to being able to get a good start on stuff. You want to do your own work. Academic honesty demands that. It's not a bad approach. You want to be able to learn this stuff, and it's a good approach to learning this stuff. But once you move past that, once you move into being a professional coder, you want to find ways to only have to write and test code one single time. You want to find ways that if that code needs to change, you're going to add new features, you need to fix a bug, you want to expand out what it can do, that I only have to make that change in one place. So these two pieces of isolating down features and functionality and finding ways to reuse functionality really play well together, because it's going to mean that if I can write things into a component, I can make things reusable. If I want to isolate out code, I'm probably going to put it in the same method. I want to create a same interface over the top of it. I want to allow it to be called from multiple places inside of my solution. Most often, though, it's going to be part of a bigger class. I'm going to have a class that has a bunch of features that allows us to do a bunch of different functionalities. And I can even customize that functionality as you come in. So you can think of it this way. As you install software on your computer, you don't just take the same software that's on everybody else's computer. You customize it to what you want. So your video game has your preferences for how you do controls. Your Microsoft Word has your preferences for what's your default font and color scheme and all that sort of stuff is going to come up. And so that's what we want to be able to do within software. We want to be able to create customized components that lets us define pieces. So step one inside of there is determine the scope. When I wanted to build a component, I want to base the functionality of that component off what's the types of things I want to do. So in the I/O world, we're going to read something, we're going to write something, we're going to calculate something, we're going to do something along those lines. And that scope should be general enough that many people can make use of it, but specific enough that it gets something useful done. So I don't want to create a scope that says I want to write all data to all databases. That's too generalized. That's leaving too much work for me to do. That's basically like me saying to you, I want to give you an application that allows you to write very specific code. So hey, here's a text editor and a compiler. No. I want something more specific. That's why we have NetBeans. NetBeans only works in Java, or at least for that version of NetBeans we're using. But it gives us a Java compiler. It gives us, code complete. It gives us a bunch of stuff on top of that. But I don't want it to be so specific that I can only build one type of Java application. Here's a tool that only is good for building loop statements. That's too specific. I need to do things other than loop inside of there. So past that, then, I needed to define an interface. I wanted to find something that the component's going to do for me that really gives me a feel. So in our application, we are writing data to a file. And so I want to define what data is going to store. I want to write methods to write that data to a file and read data from a file. I want to maybe have a validation method to check, is this data valid before I go in? Generally speaking, it's all the business logic and details. It might only be one method that I need to complete the scope of everything that's going on inside of that. And then step 3 is providing customization options. So when I'm reading and writing to a file, do I have to hard code what file I'm reading and writing to? The file name doesn't always have to be the same, does it? Can't I allow that to be customized and tweaked? I can pick the name of the file. I can pick the separator character that goes between characters in the file. I can pick the number of spaces that get put in, all sorts of different details inside of there. I can allow these things to be passed into the component, typically using a constructor. I can also do getters and setters. But it allows me to customize that file, that component, that whatever I have going on in such a way that it can be used by many different sources and can be used in many different contexts as well. Then I build that component and I test that component. I ideally want to test that component somewhat independently. Oh, sure, I can test it within the GUI. That doesn't mean it's going to work in every context. I want to test it in such a way where I know it's going to work isolated from the GUI, and I can test all the different test cases that the GUI might not come across. And so when somebody else goes and reuses this, I have a good feel that it's going to work for them. So I'm challenging you within this week to build a component. To build an I/O component that's going to write data to a file that's going to be a separate class from within the GUI. And within the demo, we've built up to this point where we can build it, we can put this stuff together, we can make it all happen. And so we want to have a component that manages the file and a way of passing information to this component within managing the file. And this is the trick that we're going to try and implement within the demo. Now, in my opinion, if you understand the concept of what a component does, that we just talked about here, building the code from a component should make it easier because it's less things to track at once. I can have a GUI, and I have a line in the GUI that says write this to a file, and I can forget about it. And I can have an implementation of write this to a file that I can implement and test without having to worry about the GUI and having that all up and working. And then I can just put the two of them together, and hopefully auto-magically they'll work. Some of you might not think as abstractly. You might not be able to think, if you don't see steps 1 through 10 in a row, you might not be able to remember the jumping around and stuff. That's okay. You're not wrong. You're not anything except for experienced in a different way. You've done things differently in the past. And this is a chance for you to practice that. Part of learning to code is changing the way you think. Some of you are probably very procedural thinkers. You're very good at this. If I have 10 lines of code, I can put them 1 through 10 and write them and make that stuff happen. But maybe this abstract thinking about components and different pieces and where lines go and interfaces, maybe that's tougher for you. And others might be the opposite. You might be like, oh, this interface stuff makes perfect sense. I just can't get my lines of code in place to the details and the semicolons and curly brackets. They drive me crazy. And both of those are valid positions of where you come from. It's just the way you were born, the way you think, the way you've been taught, the way nature, nurture, who knows exactly how you got here. What I'm saying is the way you're thinking right now isn't important. What you need to do is practice thinking in the ways you'll see in the demo. So take this idea of a component and try it out. If you can't get it to work and you have it already working in a different way, then turn it in that way. That's fine. But I want you to try it out so that way you can grow your experiences, grow your thinking, to be able to think both in terms of lines of code that are being executed, like a main method, but also in the idea of components, GUI components, I/O components, and how these things get plugged in together. Because once you get into 351, the next Java class, the advanced Java class, you have to be able to understand components. You have to be able to plug them together, because that's the only way you can build websites. That's the only way you can build web services. And really the only way you can build database access as well. All right, so check out the demo, give this stuff a shot, and definitely ask for help if you're not getting it. Even if you have the assignment done, come back and ask for help. Send it over. Say, what am I missing? What am I not seeing here? And work on that, because this is really the great chance to be able to expand your thinking, expand your mind, and be able to learn both the procedural side of programming and also abstraction.